done. And then from there, let me pin. So, okay. The thing is, I'm not sure if you are also able to refer to that textbook, because I know the phone that you are using is obviously where I sent that textbook, but it's fine. Just like I said, for today.
With me.
Oh, you got it, ne? So
yes,
you can go to page 6, page number 6.
I'm on page 6.
Yeah, so can you see 2.1, which is that expression over there?
2.1.
Yeah, 2.1 on
Yes,
page.
I can see.
Wait, let me see. Is it page 6? It should be, no, it's page 8.
Page 8.
Yeah, on page 8, 2.1, you can see that problem there. It's already solved on the question on that textbook, but I want us to just work it out without having to refer to the textbook. I just wanted you to see exactly where I got that problem name.
Yes, sir.
Okay, so just to make it simple, I normally spend much of my time explaining and also asking myself questions on your behalf, such that I ask myself a question and at the same time I'm still going to answer that question. And again, as the lesson goes on, I'm going to give you an opportunity to ask questions. So feel free to stop me at any time in case if you're getting confused, or otherwise, if you've got any question, you can just stop me and ask a question.
Yes, sir.
And the other thing that I wanted to mention, don't feel worried when you feel like you're getting confused or it doesn't make sense or anything of that nature. Normally, when we start, it might be a bit blurry, but as we move on, that's when you get used to my teaching style, and again, you'll be able to then ask any questions. But for now, I want to show you how to solve that type of a problem. And again, I'm going to emphasize the most important points of which I know you'll be using throughout your grade 10, 11, and 12. So before I start with that problem, I want to make sure that you understand something which is very, very much important. So let's see. Normally in mathematics, we are dealing with numbers, and again, we are dealing with letters. So remember, Shreyas, you don't need to write every time when I write something. Remember, I'm recording this lesson, so I'm going to make it available to you just in case if you might need to write some notes. You can just have a calculator next to you. So I'm trying to indicate to you that in mathematics, or mathematics in general, it comprises of numbers and letters. So numbers starting from a negative number to 0 and up to positive number. So in this way, I'm just generalizing to say in mathematics, you might be dealing with numbers like negative 101, negative 111, negative 1,000, negative 2, negative 1, or any number which is a negative number. That's number one. Number two, obviously, you've got negative numbers followed by 0. So 0 is in between negative numbers and positive numbers. Just like on a number line, you know you've got 0, then in that direction, you've got negative values, negative 1, negative 2, negative 3, negative whatever. So the counting is endless. So in between, you've got 0. So from 0 in that direction, you've got 1, 2, 3, 4, whatever. The counting is endless. So that's what I meant. Let's say you've got 111, 2, 3, 4, 07, whatever number. It could be 1 million, whatever number. So on that part, I just wanted you to notice that in mathematics, you might encounter this type of numbers. So when it comes to letters, it's A, B, C, D, E, F, G, all the way up to Z. So in terms of letters, you are dealing with A up to Z. So in short, mathematics comprises of numbers and letters, and in most cases, they combine the two. So there will be a point where you're dealing with letters combined with numbers. So this is the most important information that you need to know. So Shreyas, what I've explained with regard to the numbers, do you get me on that one?
Yes, sir.
And then what I've explained with regards to letters, do you get me on that?
Yes, sir.
Okay, great. So now I'm going to remove all of this and give you some examples. So remember, in primary, they used to give you equations such as maybe, let's say, 2 plus 4 minus 7, it's equals 2, and they wanted you to give an answer. So this is an expression in terms of numbers, which is what I was referring to. And again, you might be having, let's say, negative 8 plus 7, let's say minus 100, and they want you to punch all of that on a calculator and give an answer. So let's say this is primary stuff. So now let's come to high school stuff where they introduce some letters. So they can say, what is A plus A, B plus B plus C plus H A minus J. So can you see, you've got an expression in terms of letters, of which they can want you to work out the whole of that. What you need to do is to obviously check the like terms. How many A's do you have? Obviously, you've got 1. How many B's do you have? You've got 1, 2 over there. How many C's have you got? It's just that one. H is just that one. J is just that one. Then you know when you work out that expression, you are only concentrating on those 2 B's. Then from there, let's get to where it gets a little bit complicated. So it is this part that I'm going to explain, where is the combination of letters and numbers. So let's say you've got 2x plus 4y minus 7x plus 3, let's say p. Can you see? This is an expression where you've got the combination of a number and a letter. The combination of a number and a letter. Combination of a number and a letter. A number and a letter. So, Shreyas, what makes a term? A term is that number which is separated by a sign of plus or minus. So most importantly, a sign of a plus or a minus separates terms. So that means there I've got a sign, which means this is a term and this is also a term. So I've got a sign there of a minus, which makes this a term. There I've got a sign of a plus. It could be a minus. As long as it's a sign of a plus or a minus, it means you've got a term. So in short, a sign of a plus or a minus separate terms. So I'm not sure if up to this point you understand, Shreyas.
I understand, sir.
Okay, great. So now what I'm going to do is to remove all of this. Remember, I'm only doing this to prepare you for when we answer these problems. So one thing for sure, there will be a time where I take you through the basics so that you understand when we say we are solving or simplifying, what exactly are we doing. So just a mini lesson, a mini lesson on that. In mathematics, Shreyas, we do normally we normally do two main things, which is simplifying and solving. Let me say simplify and solving. These are the two main things that we do in mathematics. So when you simplify, it's more like you are given either a long or a complicated expression which you must simplify and write it in its simplest form. For example, let's say 2 times 3 plus, let's say, 4. So this is what we call an expression. So this is what we call an expression. How do you see an expression, Shreyas? An expression is that mathematical problem which does not have an equal sign. So for an expression similar to this one, you just ask yourself, do you see an equal sign over there? An answer to that question, it's no. So since you do not see an equal sign, it means it's an expression. If it's an expression, what do? You simplify. When you simplify, what exactly are you doing? You are writing the whole of this in its simplest form. What is the simplest form of that? It's actually this times that, which is what? 6 plus 4, which is equals to this plus that is 10. So 10 is the simplest form of that expression. Shreyas, before I go deep or start explaining that part of solving, do you have any questions over there, or does it make sense so far?
It makes sense, sir.
Okay, so remember, this is just to prepare you to answer those questions. I will have to prepare for that lesson where we are not solving anything. I just take you through all the maths basics. So now let me explain what exactly we are doing when we are solving. So when we solve, that's where we've got an equation. That's when we'll be solving. Shreyas, how do you notice an equation? An equation, obviously, let me say, with an expression, there's no equal sign. But with an equation, there's an equal sign. So obviously, as we do more and more of these problems, that's when you'll be able to differentiate between an expression and an equation. So an equation could be something like 2. They can use any letter, Shreyas, any letter from A up to Z, but normally they like using X. So let's say 2x plus what is it? Let's say plus 1 is equals to, let me think of something, that divided by, let's say 7, because that 6 divided, okay, let's say 7. So Shreyas, let's say you are given something similar to this name. So if you are given something similar to this, the first thing that you should ask yourself is that, is it an equation or is it an expression? Then, because you see an equal sign, it means it's an equation. When you've got an equation, what do? You will be solving. What are you solving, Shreyas? You are solving for the unknown. What is the unknown? The unknown is a letter on the equation. So at all times, Shreyas, the unknown is represented by a letter, which could be any letter from A up to Z. So that means over there, I could have used 2 and use a plus 1 minus 7. I could have used 2b, a, and all of that. 2c, d, e, f, g, h, I, j, all the way up to z. Hence, I've indicated that normally they like using letter x, which means in this case, because we already know this is an equation, when we've got an equation, we solve. What are we solving? We solve for the unknown. What is the unknown, or how can you identify the unknown on an equation? An unknown is represented by any letter from A all the way up to Z. Remember, they like using letter X, which means on this equation, we'll be solving for letter X. So letter X is the unknown. So Shreyas, before I solve that unknown, just like I did simplification with that expression, I want to ask you something. What number, when multiplied by 2 plus 1, will give you or will be equals to 7? Shreyas?
Yes, sir.
3. What number is 3, ne?
Yes, sir.
Okay, great. So I want you to understand what that 3 means. Ne? So that 3, it simply means the unknown on that equation, the unknown, which is 3. It represents, or it's represented by letter X. So when you solve, you want to know the actual value of that unknown, of which the unknown in this case is letter X. But remember, you might have used your head to come up with that 3. So Shreyas, tell me, did you use your head, or did you do a calculation to find that 3? How did you get that 3?
With the calculator.
So you did some calculation to find that 3, ne?
Yes, sir.
Okay, so now in some cases, you might find that you've got a very complicated equation, whereby with that complicated equation, you need to follow mathematical procedure in order to find the actual value of the unknown. So in this case, I've just given you a very simple equation to solve. So the reason why I asked you what number when multiplied by 2 added by 1 will be equal to 7. I wanted you to have an idea of exactly what you're doing when you solve. So let's now follow mathematical procedure to answer that question, or otherwise to solve or calculate for the unknown. So I'm not sure if at this stage you are able to solve that equation using mathematical procedure. Do you think you can be able to solve that equation, Shreyas?
So I'm going to try it.
So you can give it a try by guiding me in terms of how you would go about finding the unknown.
Yes, sir.
So it's either you write it down while explaining to me, or otherwise you just tell me how you'd go about solving for the unknown.
So it will be 2x plus 1, which equals to 7. So to get the answer 7, you'll have to take 2 times 3, which will give you 6, plus 1, which will give you 7.
Okay, now I understand. So I'm now going to teach you how to mathematically find that 3, because already you know that the value of x is 3. So what I'm going to be doing, it's exactly what I wanted you to do when I asked for that question. So Shreyas, if you are given an equation similar to that one, when I say you follow mathematical procedure to calculate the unknown, this is what you do. I'm going to, I think when we get to that stage, when we solve equations, I will start with the basics of trying to explain to you exactly how you do it. But for now, I'll just solve for this one. So normally, let me actually remove all of this. Let me remove all of this and rewrite that equation. So that equation was 2x plus 1 is equals to 7. So Shreyas, when we solve for the unknown, so did you understand that part of a of an equation, solving the unknown, what is the unknown and everything? Did you understand that part?
Yes, sir.
Okay, just so that I'm confident, when you are given this thing, is it an expression or is it an equation?
An equation.
Why do you say it's an equation?
Because of the equal sign.
Because you've got an equal sign. So when you have an equation, what do?
You find
We
the
solve.
unknown.
Yes, we solve. What are we solving? We solve the unknown. Ne?
Yes, sir.
Shreyas, in this case, what is the unknown?
The unknown value is x.
The unknown is represented by letter X, ne? Which means when we solve, in this case, we solve for the value of X. We want to know what X value, when multiplied by 2, added by 7, will be equals to 7. So when added by 1. So now, in order for us to get the X value, we need to follow mathematical procedure in order to find the actual value of the unknown. So that's where the tutoring part comes in. So my role is to guide you and help you and make sure that by the end of this year, you know how to solve. So only if you can be able to know how to solve Shreyas, you will never go wrong in mathematical equations, because even though you're doing a lot of chapters, but I'm going to emphasize more on what I know that you need the most. For example, there are some calculations which you might not be continuing with when you do grade 11 and 12. So I'm going to emphasize that part which I know is the key throughout your life, which is solving for the unknown. And again, simplifying the expression. And most importantly, I'm going to take you through the maths basic rules. So if you can know the maths basic rules, you won't struggle in grade 11 and in grade 12, because normally when someone who's in grade 12 saying maths, it's difficult, Shreyas, never worry that much when you hear someone making such comments, because you might find that they haven't learned the maths basics, of which when we emphasize those, when you get to matric, you will easily understand when they teach you in class. So this given problem, Shreyas, when you solve, this is what you want to do. You want to have the letters on the left of the equal sign and have the numbers on the right side of the equal sign. And remember, it depends on the type of equations that you are given. So in this case, you are given an equation where you want to have all the numbers on the left and all the numbers on the right. So in grade 10, in most cases, you are given equations which requires this type of approach. So Shreyas, let's have a look at our equation. Do we have numbers on the left side of the equal sign which does not have letters?
Yes, sir.
What number is that?
1.
It's 1. On the right, do we have numbers which does not have letters?
Yes, sir.
Which is 7. On the right, do we have numbers which have letters?
No, sir.
Okay, great. So, can you see? This is what we are trying to achieve. If we want to have letters on the left, numbers on the right, means we have to move all the numbers which are on the left to the right, isn't it?
Yes, sir.
Which means we are going to move 1 to the right. So that's what they mean when they say you transpose. Nay. So if you move 1 on the right side of the equal sign, what are you remaining with on the left?
2x.
You remain with 2x. Then you say it's equals to, obviously 7 was there already, isn't it?
Yes, sir.
So when you transpose, what happens to that one? How do I write it on the right side?
You have to add. You have to take the 1. You minus
Mhm.
you minus 7 and 1.
So how
7 minus
do I
1.
write it?
7 minus 1.
Okay, 100%, 100%, Shreyas. If you know this one, and you will never forget when you transpose, you change a sign, I'll be very much happy. We won't struggle that much. Obviously, can you see, if I hide 2x is equals to the whole of that, can you see, you've got an expression that you need to simplify. Can you see? So
Yes,
it's
sir.
more like now we've got a combination of primary and high school stuff. So that's how it gets complicated. At primary level, they just say 7 minus 1, and they want you to simplify. Then when you get to high school, they combine numbers with the letters and equate so that you are able to solve. Can you see how complicated it gets? And if you are confident with basics, no matter how complicated it gets, you will never go wrong because you know the basics, which is what I'm going to emphasize. So now let's simplify that part. What is 7? 7 minus 1.
6.
It's 6. So now, obviously, because we want to have letters on the left and numbers on the right, that means we need to remove that 2. Can you see?
Yes, sir.
So do you have an idea of how do we remove that 2?
We can leave the x how it is and take the
Mm-hmm.
2 and divide it by 6.
100%. So how? I'm going to say 6 divided by 2.
Yes, sir.
Great, great. So that means we divide by 2. Why do we divide by 2? It's because we want it to cancel so that we remain with x. Nay. Obviously, what you do on the left, you do on the right. So that means x is equals to, obviously,
3.
is 3. Can you see? So that is what I wanted you to do that time when I said, how can you mathematically solve for that equation? So can you see how you get that 3?
Yes, sir.
So let me now show you something. I'm very much happy that your level of understanding, it's in good state. It's actually where I wanted it to be. So let me show you something. Let's say you've got a 7y minus let's say 2x minus 4, it's equals to let's say 4. Yeah. So Shreyas, I don't want us to solve that equation. I just want us to make sense out of that equation. And I'm going to guide you to do this. Shreyas, is this an expression or an equation?
An expression. Sorry, sir. It's an
Say that
equation.
again.
It's an equation.
Why are you saying it's an equation?
Because of the equal symbol.
If we've got the equal symbol, what do?
We have to solve for the unknown.
We have to solve. We solve for the unknown. What is the unknown?
The unknown is x and y.
The unknown is x and y, which means in the end, you must tell what is the x value, what is the y value. So whatever answer that you get, when you substitute it there as a number, and punch the whole of this on a calculator, it has to give you 4. Why? Because you said the whole of this is equals to 4. So that's what I meant when I said we are not going to solve this. It's just to make sense out of it. So it seems like, Shreyas, you are now able to understand equations. So now let's get to the business of the day. Can you see, in this case, Shreyas, are you seeing any equation or expression?
I'm seeing an expression.
Why are you saying you are seeing an expression?
Because there are no equal symbols.
If we do not have equal symbols, what do?
We have to simplify.
So when we simplify, if we have to explain to a primary kid, what exactly are we doing?
You have to solve for simplify to get your simplest answer.
100%, Shreyas. So now that you understand the concept, where I come in is to train you on how to simplify different types of expressions from complex to the simplest. So now 2.1 obviously is what is it? It's minus 1 over 6. It's a squared b, and then what else have we got? We've got a bracket, so that is 6. It's 6abc minus 12ac plus 18ab. Okay, so Shreyas, if I had to train you on this, I wasn't going to start with that problem. So normally it's best to start with those simple exercises just to prepare you to this type of equations. So Shreyas, let me try to come up with an expression that will first go through before we get to that one.
Yes, sir.
So let's say we've got AB into A plus B plus let's say C. So Shreyas, I'm going to quickly do this on your behalf. Next time, you will also do the same without me having to ask you after each answer. So Shreyas, this is an expression. Why is it an expression? Is because I don't see an equal sign. When I don't see an equal sign, what does it mean? It means I have to simplify this given expression into its simplest form. So in this case, because I've got that which is called coefficient, and I've got all of that inside the brackets, that means I have to multiply the coefficient by the first term, multiply the second term by the same coefficient, multiply the third term by that same coefficient. Remember, what separates a term is a sign of a plus or a minus. So obviously, when you multiply this by that, what are you getting, Shreyas? Do you want to guess?
An A squared.
An A squared. How? Okay, no. Give me a full answer. When you multiply AB times A, what is it?
A squared B.
A squared B. So, do you know the basic rule that you used in order to get A squared B?
Not no,
Not the
not
rule, no.
yes, sir.
So, you just know that when you multiply A, then it becomes A squared, isn't it?
Yes, sir.
So, Shreyas, I want us to be very, very careful on that one. The reason to that is because those who say metric maths is difficult is because they are still in a similar position as yourself, where they don't understand how do you come up with that A squared. So that's what I want to emphasize. Either sometime during the week, over the weekend, or whenever, we have to go through all the necessary maths basic rules. So, Shreyas, there's a lesson of which after this lesson, I'm going to recommend that you watch. It's a lesson that I did where I teach all the maths basic rules. So, just to explain to you, there's a rule which says A multiplied by A is equals to, let me say A to the exponent n multiplied by A to the exponent m is equals to A to the exponent n plus m. So, Shreyas, I'm going to quickly explain to you this rule. So this rule, it says when you multiply the same bases, what are those bases? Those bases are A. So it could be 2 to the exponent m times 2 to the exponent m. What is the base? The base is A. Are the bases the same? Yes. When the bases are the same, you can add the exponents. So that is the reason why you've got the base is A, the base is A, the exponent is n, the exponent is m. That's why you just represent a one base to the exponent. You add those exponents. Let me give an example. Now that we've got 2 to the exponent n and m, that means this is the same as 2 to the exponent n plus m. Another example, if you've got 7 to the exponent 2 multiplied by 7 to the exponent 3, Shreyas, this is the same as 7 to the exponent 2 plus 3. Why? Because the bases are the same. When the bases are the same, you can just write one base but must add the exponents. Shreyas, I'm going to now explain that one over there. The reason why you're saying that is the same as a squared b is because it's the same as a the exponent 1 multiplied by b. Obviously there is to the exponent 1 multiply by that a, which is a to the exponent 1. So obviously you've got the same basis over there. What does it mean according to that rule? It means you can have A because you've got same basis, then you add the exponent, which is 1 plus 1 multiplied by B to the exponent 1. So obviously you simplify that part over there, which is 1 plus 1 is 2 multiplied by B. Shreyas, did that make a perfect sense?
Yes, sir.
No questions about that.
No, sir.
So, do you see now that it's necessary for you to watch that lesson where I teach the basic rules?
Yes, sir.
So now I'm going to apply all of those rules to solve for this not necessarily to solve, but to simplify. So let's go. We've got a b times a. Obviously, you said it's a squared times b. If it's 1 there, or if it's there's no number there, we just write b. There's no need to write 1, but we know there's 1 at the top, isn't it?
Yes, sir.
So Shreyas, what about that multiplied by b?
It will be a squared, b squared.
So you're saying, what sign am I writing?
Plus.
Okay, it's a plus. Then what am I writing?
A squared,
A squared,
b squared.
b squared, ne?
Yes, sir.
Okay, now let's have a look. It cannot be a squared. The reason to that is because this term does not have a. So it's more like you've got a, b multiplied by b. Can you see? Which is a multiplied by, you've got obviously a 1 there, so you've got the same basis, then it's the same as b to the exponent 1 plus 1, which is just a multiplied by b squared. Can you see?
Yes, sir.
So does it make sense? Can you see your mistake on that one?
Yes, sir.
Okay, great. So now let's move on to that other part. So AB multiplied by C. What are we getting, Shreyas?
We're getting, it will be plus ABC.
It will be plus ABC. Nay, I'm in agreement with you on that one. So Shreyas, please do make sure that you become very, very much careful when you're dealing with this type of multiplications, because if you're not careful, then with just that mistake of having a squared, then from that step going all the way to your final answer, everything is wrong. Nay.
Yes, sir.
So now the next step is to check if we've got common factors. If we've got common factors. Do you know what is meant by common factors?
Yes, sir.
So do you see common factors on that expression over there?
Yes, sir.
What are the common factors?
Three A's, three B's, and a C.
Mm-hmm. Okay, so how many terms have we got over there?
3.
100%. We've got 3 terms. I'm going to make blocks for each term. So these are the 3 terms that you're talking about, isn't it?
Yes, sir.
So Shreyas, when we talk about like terms, it means when you look at this term, you should see the same arrangement of letters. I'll give an example. Let's say we had x squared plus y plus b to the exponent 3 minus x squared plus c. So how many terms have we got on that expression?
5.
5 terms, ne? So I'm going to identify the like terms. When we talk about the like terms, Shreyas, we are not talking about using A in that term, using A also in that term, and also seeing B in that term, or maybe B there, B there, B there. Those are not the like terms. Ne? Remember, Shreyas, the whole of this is a term. Ne? The whole of this is a term. So you said here we've got 1, 2, 3, 4, 5. So I'm going to do just like I did there. So this is a term, this is a term, this is a term, this is a term. Name. So Shreyas, when we talk about the like terms, we are talking about the whole of this repeating itself somewhere on that expression. So can you see there I've got ax squared, I also have ax squared over there. Do you agree?
Yes, sir.
So I don't have another y on that side. So this is the only y that is available, isn't it?
Yes, sir.
And again, I don't see b to the exponent 3 on this side. It's only that one, isn't it?
Yes, sir.
I don't see any other c on that expression. It's only that one, isn't it?
Yes, sir.
Which means I can add these two terms, not necessarily to add, but I'm going to say this term minus that term, which means it's 0, isn't it? Do you understand why it's 0?
No, sir.
Shreyas, do you?
Yes, sir.
Okay, it's 0 because this is positive x squared, isn't it?
Yes, sir.
And this is minus x squared. So can you see it's 1 x squared minus 1 x squared, which is equals to 0.
Yes, sir.
So that is the reason why I'm saying it's this minus that is 0. So you are remaining with y plus b to the exponent 3 plus c. So this is the end of that expression. Why? Because this cancelled and you don't have any other like terms to work out that part. So now let's go back to that equation that I've given to you. So Riyadh, on this expression, do you see another a squared times b?
No, sir.
No. So that means this is just that. So Shreyas, do you see a times b squared on that expression?
No, sir.
Then it means it's just a b squared. Do you see abc?
No, sir.
So that means this is just abc, which means there is no a like term on that expression. There are no like terms. So do you now have an idea of what it means by like terms?
Yes, sir.
Okay, great. So now let me remove the whole of that and let's try to work out that equation. But still, I don't feel like this is a good starting point. I think instead of having to use what's in the textbook, I'll just derive my own expressions, which will prepare you to this type of expressions. So before we start, Shreyas, can you just do that introduction about that given problem?
So, what do you mean by the introduction? Whether it's
By the intro, yes.
so it's an expression which you must be simplifying.
So it ends there, isn't it? It's an expression which must be simplified. So now let's simplify. So obviously, we've got that which is what we call the coefficient of the whole of that. You understand that part, isn't it?
Yes, sir.
So remember, this is more like 2 into the whole of this. So that is just one thing, which is 1 over 6 a squared times b. So don't be intimidated when you see it being that long. So now let's start. How many terms are there inside the bracket?
3.
It's 3 terms. So obviously that means we're going to say that multiplied by that multiplied by that multiplied by that. Do you agree?
Yes, sir.
100%. So now let's multiply the first terms. Obviously we have -1/6 multiplied by a squared multiplied by b. This is multiplying 6 multiplied by a multiplied by b multiplied by c. Do you agree with that part, Shreya? Do you understand that part?
Yes, sir.
Okay, so now let's multiply. So obviously a -1/6 multiplied by 6, what is it?
It's 1, sir.
Be careful, Shariat, be careful. Did you punch it on a calculator?
Yes, sir.
So what is -1/6 multiplied by 6?
Times 6.
Yes.
-6. I mean, -1, sir.
-1, 100%. So Shariat, going forward, you need to be very, very, very careful about the negative sign. Né?
Yes, sir.
So obviously that multiplied by that, it's -1. Then you move to that one. What is a squared multiplied by that a there?
It will give me a to the power of 3.
Shreyas, using that rule, are you able to explain to me how are you getting a to the exponent 3?
Yes, sir. Because a
A,
times, for example, an times am will equal to a to the power of n plus m. So for us, it will be a to the power of 2 times a, which will equal to a to the power of 2 plus 1.
100%, which makes it a to the exponent 3. I'm very, very much happy, Shreyas. If you are now able to understand this maths basic rules, when you watch that lesson, please do make sure to watch it from the start up until the end, because that's where I teach all the maths basic rules. So after you've done that lesson, you won't struggle when we continue with any calculations. So now, where are we? We are now on b times b, isn't it?
Yes, sir.
So what is b times b?
B times b is b to the power of 2.
B to the power of 2. So do we have c there that we can multiply with that c? We don't have, isn't it?
Yes, sir.
So that means we just write c. So can you see how you work out that first part?
Yes, sir.
So we do the same for when we multiply that middle term. So let me just remove all of that and write that one over there nicely. So remember, Shreyas, can you see it's -1? So we don't really need to write that -1. Are you aware of that?
Yes, sir.
It's like 1a. There's no need for us to write 1a if it's just a, isn't it? Because we can just say a. We know there's that invisible one over there, isn't it?
Yes, sir.
And again, we've got that one which is an invisible power over there, isn't it?
Yes, sir.
Okay, great. Which means we can write this as negative a to the exponent 3, what else? B squared c. Do you agree with that part?
Yes, sir.
Shreyas, something very, very much important. Remember, when you write these answers now, you need to arrange the letters in alphabetical order. Do not write negative c, a, b squared, a to the exponent 3. Do you understand that part?
Yes, sir.
Always rearrange them in alphabetical order from A all the way up to the last letter. Very, very much important, that part. So now let's get to that one. So obviously we've got minus 1 over 6 times A squared times B. This is multiplying a negative 12AC. Do you agree, Shreyas?
Yes, sir.
So what is negative 1 over 6 multiplied by 12? Negative 12.
Negative 12
Yeah.
is 2.
So let's say is positive 2. Nay.
Yes, sir.
So now, obviously, a times a, you know very well that it's a to the exponent 3, isn't it?
Yes, sir.
So obviously, we don't have any other b to multiply with, so it's just b, and again, there is just c. We don't have any other c to multiply it with. Then it ends like that. Do you agree with me on that part?
Yes, sir.
Which means the middle term we've got positive. Can you see the reason why I wanted you to say positive 2? It's because that sign over there, it then changes to a positive sign, which means it's positive 2 to the exponent 3bc. Do you agree with me so far?
Yes, sir.
Okay, great. So now let's move on to that part. So obviously it's negative 1 over 6 a squared b multiplied by what is it? It's positive 18b. Nay.
Yes, sir.
So what is negative 1 over 6 multiplied by 18?
Negative 3.
Negative 3. What is, do we have a that we can multiply with each other?
No, sir.
Then we just write it as a squared, isn't it?
Yes, sir.
Then that part, obviously it's b squared, isn't it?
Yes, sir.
Which means we've got minus 3a squared b squared. So Shreyas, let's now try to check if we've got any like terms. Remember Shreyas, the whole, okay, let me give it to you as a question. How many terms have we got?
3.
We've got 3 terms now.
Yes, sir.
So this is a term, this is a term, and this is a term. So do you see any like terms?
Yes, sir.
What are those like terms? Let me say this is 1, this is 2, this is 3, so that you are able to tell me which ones are the like terms.
Block A, block 1, it will be a to the power of 3, and in block 2, a to the power of 3.
Okay, let me explain this again. I'm glad I asked you this question. So Shreyas, let me do this. Let's say we've got a that minus x squared plus x y squared plus 2x squared. Shreyas, tell me, how many terms have we got there?
4.
1, 2, 3, 4, 100%. So now I'm going to make boxes for each term. Boxes for each term. Boxes for each term. So how you do these boxes, you include that sign because this sign is for that. This sign is for that. This sign is for that. The sign for this one, obviously, it's positive. So, Shreyas, I'm going to explain you how this thing of like terms works. Then you will guide me on that one. So when we talk about the like terms, Shreyas, the whole of this, it's a term. The whole of this, it's a term. The whole of that, it's a term. So you cannot say a x squared is a term which is the same as x squared. Why? Because x squared times y is a term on its own. So if you say x squared is the same as that x squared, it's more like the whole of this. It's not a term. So when we talk about a term or like terms, you must look for another term which has x squared and y. Do you see that term along that expression?
So can you please repeat what you said now?
Okay, so when we say like terms, we are not referring to you seeing x squared there, x squared there, and x squared there, and say this is a term which is a like term to that one and that one. That's not how terms works. So the whole of this, can you see the whole of this in a box?
Yes, sir.
So the whole of this is a term. So when you look for like terms, you must look for another term which has got x squared times y, not only x squared.
Yes, sir.
So now my question to you, do you see a term that has got x squared times y?
X squared times y. Yes, sir. X y to the power of 2.
Shreyas, let me say 1, 2, 3, 4. My question again, do you see another term which has got x squared times y?
No, sir.
The answer to that is no. So can you see, I wanted to confuse you with that one. So you must be careful of where is that squared.
Yes, sir.
So Shreyas, do you see another term which has x squared?
No, sir.
Okay, now I understand. So that means there's a confusion that we need to work out. Only if we can work out this one, I can tell you, going forward, you will never get lost. So that means I need to teach you how to identify like terms. So when we talk about the like terms, Shreyas, do you agree that there's that one there?
Yes, sir.
So there is a like term which has x squared. It's that one over there. Can you see? You've got 1x squared. There you've got 2x squared. So when we talk about the like terms, we are talking about those terms which has got the same how do I explain it? The same term written in terms of a letter. For example, if you've got 4y squared, you can work it out with 7y squared because you've got a 4 bananas there, you've got 7 bananas there. Can you see?
Yes, sir.
So let's say there we've got minus 1 apples. Can you see another apples along that expression?
Yes, sir.
How many apples have you got?
2.
Which means you can say minus 1 plus 2. Whatever answer that you get when you punch on a calculator is that number x squared. I'm not sure if it makes sense, Rian.
No, sir, it makes sense now.
It makes sense, ne?
Yes, sir.
So now, do we have x y squared on that expression?
No, sir.
We don't have, which means the like terms that we had, it was just that one of x squared and that one of 2x squared. It makes sense now, ne?
Yes, sir.
Which means if you were to simplify that, you were just going to have x squared times y. Obviously, when you punch negative 1 plus 2, you get minus 1x squared. Do you agree with me on that one? Do you understand that part?
Yes, sir.
Then also you remain with that plus x y squared. Reason to that is because you cannot work it out with anything else. So how many terms have you got there, Triad?
3.
Are there any like terms over there?
No, sir.
Then it means this is where it ends. So your confusion, you were going to say you've got x squared there, x squared there. So can you see now that confusion, it should be gone, or otherwise it's slowly going, isn't it?
Yes, sir.
So now let's go back to the main problem. So Shreyas, let's check. Do we have a like term similar to that one there?
No, sir.
We do not have, which means it remains as a to the exponent 3b squared c. Now, Shreyas, have we got another like term which has got a number a to the exponent 3bc?
No, sir.
We do not have, which means it remains as 2 to the exponent 3bc. Obviously, no term for that one, isn't it? Then it just remains as a squared b squared, which means this should be the end of that problem. Let's quickly try to check if this is correct. You said you've got that textbook that I sent you, isn't it?
Yes, sir.
So can we quickly check if it's the same as that one? You'll let me know.
So it's exactly the same.
Exactly the same. So can you see, Shreyas, it's not really that much complicated. You just needed to know the maths basic rules. Do you now believe when I say you need to watch that lesson where I teach the maths basic rules?
Yes, sir.
Okay, so Shreyas, I'll just hear this from you. I think I've gathered some of the information that I wanted out of this lesson. So now let me know if we should continue with this or spare it for next lesson.
Yes, sir.
So which option do we do continue with these questions on next lesson?
Yes, sir.
Okay, great. So we'll just end it there for today's lesson, but do promise me that you will watch that lesson. I'm going to send you a link. Then whenever you get a chance, just watch the lesson. Hopefully, if you happen to get a chance, maybe tomorrow after school, if you don't have homework assignments or projects. So otherwise, sometime just make sure to watch that lesson, because as soon as you've watched that lesson, doing these problems and other upcoming problems, it won't be a hassle. So Shreyas will just end it here for today, and then I'll see you on our next lesson. Would you say on our very first lesson that we're having, would you say you are comfortable with my teaching style, and also do you understand my teaching style?
Yes, sir.
Okay, 100%. So Shreyas, what I'm going to quickly do, I want to just pause or stop this recording.